Your delta H of your reaction will tell you how many kilojoules of heat will either be absorbed or released in a chemical reaction. So you'll be given a delta H value like you have here. It'll be negative or positive. If you have a negative delta H value, we know that that means that we have an exothermic reaction. Down here we have a positive delta H value. That means that we have an endothermic. Heat gets absorbed into the reaction. With the problems that you're going to see, this delta H value is based off of this perfect chemical reaction when it's balanced. So if I balance this one out with a 2-3-2, in this reaction it says for every 2 moles of sulfur that react with 3 moles of oxygen, we're going to make 2 moles of sulfur trioxide. The overall delta H value is right there. In these problems, you're going to be given a different amount of one of your reactants. You're going to need to first convert your grams to moles. So we have 6.44 grams of sulfur reacting with excess oxygen. So remember that we have so much oxygen, it's not going to run out. We want to know what is the heat for the reaction when we have 6.44 grams of sulfur instead of 2 moles. So to convert grams to moles first, we're going to pull the molar mass of sulfur, 32.07 grams. It's right there on the periodic table. That's equal to 1 mole. Then in the last step, the reaction, when you look at it, it says for every 2 moles of sulfur react, you have a delta H value of negative 971.4 kilojoules. You're going to use that as your conversion factor. 2 moles of sulfur is equal to negative 971.4 kilojoules. So now we can grab our calculator, take 6.44 times 1 times negative 791.4 divided by 32.07 times 2, and we get negative 79.0 kilojoules for an answer. So if we go to the back, we can check our answer real quick. When we go to the back and check our answer, negative 79.5. I didn't do something right somewhere. Let's make sure that the calculator is set correctly. 6.44 times 791.4 divided by 32.07 times 2. Yeah, it looks like calculator mode was a little off. So the 6 makes the 4 go up. So there's our negative 79.5 kilojoules of heat. Now with your endothermic reactions, they work the same way. We need a balanced reaction, which we have right there. In this reaction, it says that we have 38.2 grams of bromine instead of 1 mole of bromine. So we're first going to take our 38.2 grams and convert it to moles. Bromine on the periodic table, 79.90, so times 2. We get molar mass of 159.80 grams is equal to 1 mole. And then we have the ratio that 1 mole of bromine, when it reacts, you have an endothermic reaction, it lets out, it's going to absorb 72.80 kilojoules. Moles cancels, grams cancels. So 38.2 times 72.8 divided by 159.8. We get 17.4 kilojoules of heat. We're going to check our answer. 17.4 kilojoules. So we're right on. So with your enthalpy changes, the first thing you're always going to do is convert your grams in the question to moles, and then look at your problem. Take the number of moles from your balanced reaction, set that equal to your delta H.